Now, before I begin part 5, and I don't know what the title should be, I just wanted to read this from the previous video, talked about researching overlay networks more. Well, on the Wikipedia article about overlay network, I thought this was interesting. The internet was originally built as an overlay upon the telephone network, while today, through the advent of VoIP, the telephone network is increasingly turning into an overlay network built on top of the internet. When I think of overlay networks, I think of VPN. I'm still wrapping my mind around MPLS, but that's not the topic of today's video. Here we are going to read 3.2, Deployed Variations of the Abstract Architecture. We're on page 22, and here we go. All of the above components are logical components. They do not necessarily need to be unique systems. A single asset may perform the duties of multiple logical components, and likewise a logical component may consist of multiple hardware or software elements to perform the tasks. For example, an enterprise-managed PKI may consist of one component responsible for issuing certificates for devices and another used for issuing certificates to end users, but both use intermediate certificates issued from the same enterprise root certificate authority. So in some ZT product offerings currently available in the market, the PE and PA component are combined in a single service. We mentioned that before in our notes here. And I'm always trying to walk away with something from each paragraph. Here, I'm just noting those keywords. Okay, so with the device agent gateway-based deployment, the PEP is divided into two components that reside on the resource or as a component directly in front of a resource. For example, each enterprise-issued asset has an installed device agent that coordinates connections, and each resource has a component that is placed directly in front so that the resource communicates only with the gateway, essentially serving as a proxy for the resource. The agent is a software component that directs some or all traffic to the appropriate PEP in order for a request to be evaluated. So I think the tricky part of this section and this wording is the idea that a PEP is a gateway, like a firewall or an intelligent switch can use that as a label, PEP. Remember, PEP, Policy Enforcement Point. So I'm going to enforce a policy at that point, the intelligent switch or the firewall. And to make sure that actually works, that the PEP is being utilized, I need an agent on devices to direct the traffic there. Here they just flesh it out a little bit more. The gateway is responsible for communicating with the policy administrator and allowing only approved communication paths configured by the policy administrator. And I want to say that sentence is incomplete. It would have been nice if right here they put the word through. So the gateway is responsible for doing this, and it's responsible for allowing things that are approved through the PEP. So let's go back to our diagram here. Picture's worth 1,000 words, even if there's words in the picture. If we go back in our notes, it says that the policy administrator executes the decisions. I guess I didn't need to scroll up, because right below that paragraph is this diagram. This arrow is the one that's confusing me. And they sure did decide to put both the data resource and the gateway together. I thought the gateway was going to have another arrow to another box allowing that access, right? Because over here, this is the trust zone. The paragraph says, in a typical scenario, a subject with an enterprise-issued laptop wishes to connect to an enterprise resource. The access request is taken by the local agent, and the request is forwarded. There's our local agent. The request is forwarded to the policy administrator. The policy administrator and policy engine could be an enterprise local asset or a cloud-based service. The PA forwards the request to the policy engine for evaluation. That makes sense. So first it goes to the PA. There we go. And then the PA sends it to the PE, my favorite class in school. If the request is authorized, the policy administrator configures a communication channel between the device agent and the relevant resource gateway via the control plane. I wish I could easily do that little arrow thing, so now I could point back in this direction. I suppose that doesn't look too awful. Hope this is working for you guys. And I trying to note right here that the PE is configuring the agent to now be able to go to the trust zone. This may include information such as an internet protocol address. Oh, okay, so it can deliver us an address and port. Maybe there's a session key or similar security artifacts. The device agent and gateway then connect. An encrypted application service data flows begin. Okay, makes sense. So you still got to be encrypted during the data flow. Now, the connection between the device agent and resource gateway is terminated when the workflow is completed or when triggered by the policy administrator. So the PA, this guy could jump in anytime and just shut things down, it sounds like. Why would it do that? Well, maybe there's a security event. So that's the agent gateway model. This model is best utilized for enterprises that have a robust device management program in place, as well as discrete resources that can communicate with the gateway. For enterprises that heavily utilize cloud services, this is a client-server implementation of the Cloud Security Alliance Software-Defined Perimeter, CSA SDP. So this model is also appropriate for enterprises that do not want a BYOD policy in place. Access is possible only via the device agent, which can be placed on enterprise-owned assets. Hope that made as much sense to you guys as it did to me. So a good question would be, what type of model is used when hosting resources on a cloud? And that's just that CSA SDP stuff we read about. And I'm just going to note here that this is like the anti-BYOD approach because it's saying you need an enterprise asset. Okay, so feeling pretty good about that deployment. We can have an enclave-based deployment. This model is a variation of the one we just read. Here, the gateway components may not reside on assets or in front of individuals' resources, but instead reside at the boundary of a resource enclave. For example, on location data center. And we got a figure. Let's jump down there real quick. Here's our little cloud. The picture's not too different in this enclave. Here it looks like you need an API. This model is useful for enterprises that use cloud-based microservices for a single business process, that is user notification, database lookup, salary disbursement. And in this model, the entire private cloud is located behind a gateway. So pretty straightforward. They have 2 more paragraphs on this. So to summarize these 2 paragraphs, starting with this one, models can be hybrid. And in the next one right here, the enclave model is good for situations lacking individual gateways, but the issue, individual resource protection, can be an issue. And I guess if we look back at the diagram, especially if we're talking cloud, I can see what they mean here. Maybe it just depends on what type of cloud resource we're talking about. So next up is resource portal-based deployment. In this deployment, the PEP is a single component that acts as a gateway for subject requests. The gateway portal can be for an individual resource or a secure enclave for a collection of resources used for a single business function. One example would be a gateway portal into a private cloud or data center containing legacy applications, as shown here. So in this resource portal model, the primary benefit is that a software component does not need to be installed on all client devices. So no agent, right? This model is also more flexible for the bring your own device policy and interorganizational collaboration projects. Enterprise administrators do not need to ensure that each device has the appropriate device agent before use. However, limited information can be inferred from devices requesting access. This model can only scan and analyze assets and devices once they connect to the PEP portal and may not be able to continuously monitor them for malware, unpatched vulnerabilities, and appropriate configuration. This main difference with this model is there is no local agent that handles requests, and so the enterprise may not have full visibility or arbitrary control over assets, as it can only see and scan them when they connect to a portal. The enterprise may be able to employ measures such as browser isolation to mitigate or compensate, which is a good point, I think, because this portal, resource portal model is definitely like the less secure model. Now, these assets may be invisible to the enterprise between these sessions. This model also allows for attackers to discover and attempt to access the portal or attempt a denial of service attack against the portal. So yeah, I'm just reading. We should not use the portal model unless you know how to do this. It says well provisioned to provide availability against a denial of service attack. Now, before we finish, there is a device application sandboxing. This is another variation of the agent gateway deployment. The way you do this is by having vetted applications or processes run compartmentalized on assets. These compartments could be virtual machines, containers, or some other implementation, but the goal is the same: to protect the application or instances of applications from a possibly compromised host or other application running on the asset. And since we're talking about VMs, I already think this is the best choice. In Figure 6, let's show the figure. Figure 6, a subject device runs approved vetted applications in a sandbox. The applications can communicate with the PEP to request access to resources, but the PEP will refuse requests from other applications on that asset. The PEP could be an enterprise local service or a cloud service in this model. The main advantage of this model variant is that individual applications are segmented from the rest of the asset. If the asset cannot be scanned for vulnerabilities, these individual sandbox applications may be protected from a potential malware infection. One of the disadvantages of this model is that enterprises must maintain these sandboxed applications for all assets and may not have full visibility into client assets. Okay. The enterprise also needs to make sure each sandboxed application is secure, which may require more effort than simply monitoring devices. That's a great question then to add here. What is one downside to using what is it called? I guess we'll just say application sandboxing, like the diagram says. So sure, what's that one downside? The PEP isn't scanning the device, so threats exist. Though threats exist and can't interact with apps, they still exist, and because the organization is using this model, those threats may go unknown. So that'll do it for this video. In the next one, we'll go over the trust algorithm.